This is Bavir. This week in math, we're going to practice what we would do if we would have to go to remote learning or if you were quarantined due to either being a close contact or getting sick. All right, so I'm going to go ahead and start with our presentation, and the video will pause when it is expected that you will answer questions. So please make sure you're listening and do your best while we try this remote learning. So today what we're talking about is rational numbers, and I'll soon tell you what rational numbers are, but as part of the word, you know that right away that they are numbers. Our goal for today is that we will be able to locate these rational numbers on a horizontal number line. So on this slide, what we're going to do is we're going to continue to practice our warm-ups. If you're at home, I would ask you to grab a piece of paper to go ahead and solve these on paper. Since you may be in the classroom, you can instead just grab out your warm-up sheet and solve these two problems. I'm going to pause the video right now for you to solve them on your own. All right, let's go ahead and look at these together, just in case you made a mistake, because it won't be graded for today. I just want to see what you can do on your own. All right, so I'm going to go ahead and write $1,256 vertically, and I know whenever I don't see a decimal, it is at the end. If I wanted to, I could add 2 zeros at the end because this is money, but I notice my other money amount doesn't have zeros or change or cents, so I'm not going to go ahead and write those zeros. It wouldn't change the number, however, if I did. All right, so I know my decimals have to line up, and since I don't see a decimal in 598, I know what comes at the end, so then I'm going to line up my ones, my tens, and my 100s digits. And I'm sorry, my numbers aren't the greatest. I'm not good at making numbers with a mouse. And now I'm ready to add. I know 6 and 8 make 14, so I'm going to write the 4 down and carry the 1. 9 plus 1 makes 10. 5 more would be 15. Carry my 1. 5 plus 2 plus 1 is 8. And then 1 plus nothing is 1. So if I start at the very right of the number, I can put a decimal there. Once again, it wouldn't matter if it's there or not since I don't have any numbers after the decimal. Then I could count to the left 3 places, 1, 2, 3, and put my comma. So my answer is $1,854. Let's go ahead and look at number 2. I'm going to go ahead and write this vertically, $150. I know my decimal is at the end since I don't see one. And I notice that the second term has some cents, has 75 cents. So I'm going to add some zeros to the end of $150 to make it easier to subtract. Make a subtraction sign. I know my decimals have to line up. So before the decimal is the number 24. And after the decimal is 75 cents. And in this problem, we are subtracting, not adding. I know if I have 0, you could not take 5 from me, so that tells me I have to borrow. Can't borrow from zeros because there's nothing to borrow from, so I have to go all the way to the 5 and make it a 4. But the number right next to it becomes a 10, but I still need to borrow for these zeros over here, so I have to borrow from that 10 and it becomes a 9. My next 0 becomes a 10, but I have to borrow from that 10 so that I can subtract 5 from that first digit. So I have 10 minus 5 is 5. 9 minus 7 is 2. Carry down my decimal. 9 minus 4 is 5. 4 minus 2 is 2. And 1 minus nothing is 1. So my answer would be $125.25. Back to the slide. If you aren't doing well with these, please, please, please let me know. Okay. So this unit is all about rational numbers. And up at the top here, it says stores use different forms of rational numbers to advertise sales and promotions. As a consumer or somebody that buys things, it is important to understand what these numbers mean. So one of the first questions that there are to just jog your memory about where we see numbers in real life is, where have you seen numbers used in advertising? Give some examples. I'm going to pause the video now so you can type what your examples are within this video. Some of the places that I have seen numbers are in ads on TV. Like if I want to buy something, I might see an ad, or more or less on the computer or on my phone, they pop up. Kind of annoying when you're watching a YouTube video and there pops up an ad. What jogs my attention, though, is when something is on sale. If it says 50% off, I think, wow, this is a good deal. So that is one of the places I have seen advertising, or numbers used in advertising. I'm excited to see where you have seen it. Number 2 says, explain why numbers are important in sales advertisements. Go ahead and type your answer now. Numbers are important in sales advertisements, like I said before, is they grab your attention. If you think that a price is a good deal for something, you're probably going to go buy it. Or if you see there's a sale at maybe your favorite store, you're more likely to go shopping at that store. So those are a couple of reasons why numbers are important. Number 3, give examples of different ways numbers are used in sales advertisements. So just like in the picture, you might see a 40% off to get your attention. You might see a buy one, get one free in an advertisement, but they want to make sure that the reason they include those numbers should make you want to come in. They're not going to say, hey, I charge more than Walmart, so come buy an item at my store. They just want to make sure to grab your attention and make it so that you want to go shopping there. All right, so vocabulary. One of the vocab words we're going to work with is an integer. Integers are just whole numbers and their opposites. Do you notice how all of these numbers listed right here don't involve a decimal or a fraction, although decimals and fractions can be written to represent a whole number, but these ones don't have any decimals or fractions. So when we have integers, we have our positive numbers to the right of 0. And when you see the word opposite, every positive number has an opposite, which is negative. So the opposite of 1 is -1. And if you notice, they're both right next to 0. Same with +2 and -2. They're both the same distance from 0. All right. One important thing to note, a lot of people ask this, is 0 is neither positive or negative. So whenever you're writing an answer and your answer is 0, you don't need to put a plus sign or a negative sign in front of 0 because it's neither positive or negative. Our next vocabulary word is a rational number. A rational number is just any number that can be written as a fraction. If you notice, whole numbers are rational numbers because I can take a whole number of 5 and put this imaginary number 1 underneath it, because every whole number truly is a fraction. It just has an imaginary number 1 underneath it. If you remember from our last unit that this fraction bar means divide, so I know if I take 5 divided by 1, I get an answer of 5, which is a whole number. This one next to it says 12 divided by 4. Well, think, how many 4s go into 12? The answer is 3, and 3 is a whole number. We have not talked about square roots yet, so I'm not going to explain that one to you. Integers are also rational numbers. Remember, integers are just positive and negative whole numbers. All right. The last big picture of rational numbers can include decimals, fractions that don't make whole numbers, repeating decimals, and they also have, I can't see the bottom one, another repeating decimal and more fractions. One number that we've already learned about this year that is not a rational number is pi. If you remember, pi is a really big number that never repeats or terminates, which means ends. So pi is one number that you've learned so far this year that is not a rational number, and you'll learn about more numbers that are not rational numbers later on. All right, let's activate some prior knowledge. Number lines can be displayed in 2 ways. We've seen number lines displayed horizontally, which is just a line that goes from the left to the right. Or we can see number lines displayed vertically, which is just up or down. Today, we are going to work on the horizontal number lines, and tomorrow you'll work with vertical number lines. Right? So I want you to try to decide between which 2 integers, which remember is just a positive or negative whole number, would 3 1/4 fall. I'm going to pause the video now. I want you to take a guess. Which 2 integers on this number line would 3 1/4 fall? One thing that I notice is that it has the whole number 3. So I'm going to find the whole number 3 on my number line, which is right here. But it's not just 3. There's some extra here. That extra tells me I am getting further away from 0. So if 0 is right here and I want to get further away, I'm going to go to the right of 0. Because if I went to the left, I would be getting closer to 0. So I know 3 and 1/4 is more than 3. It's further away from 0. So it's going to be in between right in between this section right here, which is the whole numbers 3 and 4. Okay, next question kind of relates to the first question. Between which two integers would -3 and 1/4 fall? I'm going to pause the video. I want you to try to figure out which two numbers this would fall between. Okay, first thing I notice is it starts with a whole number -3. So I'm going to find that on my number line, which is right here. Hopefully I'll get better at drawing with a mouse soon. I also notice that this number has an extra fraction behind it, which is 1/4. That 1/4 tells me I've got to get further away from 0. If I go to the right like I did the last time, do you notice how I'm getting closer to 0? So this time, instead of going to the right, I'm going to have to go to the left. That's going to make me further from 0. So I'm going to start at -3. I know it's going to be right after the -3 before I get to the next whole number, which is number 4. So I know -3 and 1/4 would have to fall in between -3 and -4. So I should have made a plus sign. That would have taken me less time to write. All right, let's do some more practice. Will -3 be to the left of 0, so this direction, or to the right of 0? I'm going to pause it. You choose. And I hope you use this number line to see. Here is -2 on my number line. Here is 0. I can see -2 is to the left of 0. And all negative numbers are to the left of 0. All positive numbers are going to be to the right of 0. If you remember the number line on my wall, you will see that it's written that way as well. Okay, introduction activity. So sometimes you're going to have to label the number line on your own. I know 0 is right in between positive and negative numbers, so I'm going to go ahead and put 0 right in the middle. And I would highly suggest that you also do this when I'm doing it, just to keep your brain actively participating. All right, so to the right of 0, I'm just going to count by ones. I know to the right of 0 are all positive numbers. So I have 1, 2, 3, 4, 5, and so on. To the left of 0, I know that all my numbers need to be negative. And so just like 1 comes right after 0 in the positive direction, -1 has to come right after 0 in the negative direction. So I'd have -1. And then, just like positive, we could do the opposite. -2, -3, -4, -5, and so on. All right. This next slide, I already have it labeled for us. So I have another question for you. What are some numbers that would fall between 2 and 3? So here's 2 and 3 on my number line. I know whole numbers cannot fall in between 2 and 3 because they are right next to each other when I'm counting. They're consecutive. So that tells me I need to think of some fractions and decimals that would fall between 2 and 3. I'm going to pause the video so you can type some of your ideas of numbers that fall in between 2 and 3. If I were to think of decimals that fall in between 2 and 3, I know my whole number is going to have to be 2. Because if there's a number written after 2, that means I am further away from 0 than 2 is. So I can add some numbers after the decimal for 2. It could really be any number. I could say $2.50 is in between 2 and 3. I could say 2.9 is in between 2 and 3. Just need to make sure I start with 2 and have a number written after it. If you're super creative, maybe you had 2.000005. That would be a number in between 2 and 3. If I just wrote 2.0, that is not an example of a number that's in between 2 and 3 because 0 says I didn't move any further away from 2. This is the same as just writing the whole number 2. So 2.0 would not work. Okay, let's think of some fractions. Same as with our decimals, I know my whole number would have to be 2. then I could really choose any fraction to come after the number 2. I could say 2 and 5/8. I could say 2 and 4/11. One thing I could not do with the fraction, I couldn't say 2 and 5/1, because 5 divided by 1 is the same as 5. So that would be like saying I have 2 plus 5, which is equal to 7. So when I'm writing my fraction, I have to make sure the numerator, or the top number, is smaller than the denominator. And in this case, that is not true, so that would not work. Okay, I'm going to give you some time to do some more practicing. This time I want you to tell me some numbers that come between 4 and 5. My challenge for you this time is to type in 2 or 3 numbers that would fall between 4 and 5. Okay, remember, if we're going to talk about some decimals, our first or whole number would have to be the number 4, because if I start with a number 5 and put a number after it, like 1, that tells me I need to go further away from 0 than 5, and that would take me in this spot right here, and that wouldn't work. So some decimals could be 4.3, 4.123, so on and so forth. I'll look at your examples and give you some feedback if necessary. If I were to talk about fractions, once again, I would have to start with a whole number 4. If I had 5 and 1/2, that would tell me I'm further away from 0 than 5, and then it would fall into this spot again, and I don't want to be in between 5 and 6. I want to be between 4 and 5. So an example would be 4 and 1/3, maybe 4 and 7/12. Those are just 2 examples. There really are an infinite number of examples of numbers that you can fall between 4 and 5, because you could keep getting smaller and smaller decimals or fractions. Okay, so today what we're going to do is we're going to locate rational numbers on a number line. Rational numbers are just numbers that can be written as fractions. Can whole numbers and integers be written as fractions? I want you to write what you think, yes or no, and why. If you remember from earlier, I did say whole numbers and integers can be written as fractions, because remember, a whole number, every single whole number and every single integer has an imaginary number 1 underneath it, because remember that says 2 divided by 1, which is equal to 2. 5 divided by 1 is equal to 5. -5 divided by 1 is equal to -5. So all of these whole numbers and integers can be written as fractions. Okay, so let's practice locating numbers on the number line. So I'm going to pause this video quite a bit for you to be able to practice this. Which 2 numbers would -4.5 or -4.5 fall? I hope you said in between -4 and 5, because what I'd do is I'd find -4 on my number line, which is right here. Since there is a piece afterward that tells me I have to go further away from 0. Well, since 0 is to the right of -4, I have to go further left. So the number that's in between, or it would fall between -4 and 5. And since it's 0.5, I know that's the same as 4.5. So really I could label it right in between 4 and 5. So 4.5, don't forget my negative sign in front. And I should put a big decimal point there to let me know where that number falls. Now I want you to go ahead and find what 2 numbers 2.5 falls between. All right, I first see that starts with a 2, so I'm going to find 2 on my number line. Since there is a number after 2 that tells me I have to get further away from 0, I know 0 is to the left of 2. It is right here. So to get further away from that, I'm going to have to go to the right. And just like before, I know 2.5 is going to fall right in between the numbers 2 and 3, since I have to get further from 0. So I'm going to put a point here and label that one 2.5. Let me pause the video while you figure out where 3.7 would fall. Hope your first step was to find the number 3 on your number line, which is right here. Oh, is it going to let me write? There we go. And since it has that decimal after it, I know I have to get further away from 0. Since it is a positive number, I know I have to go to the right. So it's going to be in between numbers 3 and 4. Since it has a 7 next to it, and that is bigger than what we had over here of 5, that tells me I'm going to be closer to 4 than I am to 3. So I'm going to choose a dot that's not quite right in the middle of 3 and 4. It's going to be a little bit closer to 4. And I'm going to label this one 3.7. All right, take a minute now and tell me which two numbers 0.75 is going to be between. This one might have been a little trickier. We're starting with 0, so I find 0 on my number line. But there are numbers after the 0. One thing I notice that this number is positive, so I got to go in the positive direction away from 0. Since it doesn't have a 1 next to it, it just has a 0. I'm going to be right to the right of 0, so it tells me I'm going to be in between the numbers 0 and 1. And I know 7, this first digit 7, is bigger than 5, so I've got to be closer to the bigger number than the smaller number. So I'm going to make my dot not quite in the center, maybe a little bit closer to 1. And I'm going to label this point 0.75. Oh, the next one, I'm not even going to pause for. It says locate where 10 would be at the number line. And I just noticed right now that my 10 is in the wrong spot. And I thought I fixed that before I hit present. 10 should be over there. So I'm going to get a new color. I haven't done yellow yet. 10 is right on my number line. It's a whole number. So I got to go ahead and put a dot right on 10 and label that number 10. All right, so we did this one. You go ahead now and plot negative 0.1. Okay. One thing I notice is we start with 0 again, and I know I said 0 can't be positive or negative, but we see a negative sign in front of it. That is because there is a number after the 0. So I'm going to find 0 on my number line. Since there's a number after it, I know I have to get further from 0, and since it's negative, I'm going to go to the right. Well, 0.1 is really, really, really close to 0, so I'm going to put a dot that is really close to 0, and I'm going to label it negative 0.1. If you're struggling with where to put the dot in relation to the two whole numbers, don't worry about that. We'll continue practicing it. Okay, go ahead and plot 7.6, or tell me which two whole numbers 7.6 would fall between. All right, I notice the 7 is positive. Let's find 7 on our number line. Since there's numbers after the 7, that tells me I have to get further away from 0. So I'm going to go to the right. I know right in between 7 and 8 is going to be 7.5, since 5's our halfway mark. This is 7.6 though, so I'm going to put a dot a little bit to the left of this, or to the right, sorry, of the middle spot, and I'm going to label that one 7.6. I notice the next number is a whole number, so I'm going to go ahead and plot that one right on the whole number of negative 1, which is right here. I don't have to find where it falls between. All right, your last number to plot is going to be, or tell me which two whole numbers it falls between, negative 3 and 3/4. Tell me which two whole numbers that would fall between. Hope you found negative 3 on the number line. And since there is a number after the negative 3, that tells you have to get further away from 0. So here's negative 3. If I go to the right, I'm going to get closer to 0, so that doesn't work. I have to go to the left. And it says 3 and 3/4. Well, I know 3 and 1/2 is right in the middle, and 3/4 is bigger, so I'm going to plot a dot that's a little bit closer to 4 than it is to the center, or than it is to 3. And I'm going to label that one 3 and 3/4. How'd you do with determining which two whole numbers these fractions and decimals, or rational numbers, would fall between? All right, some reflection questions before you start your homework. Number 1 says, what number is halfway between negative 4 and negative 5? Do your best. Well, I know if I have a number line, 0 would fall right in between, and I know all negative numbers happen to the left of the 0. So I know first I would have negative 4, then I would have negative 5. I know if I'm going to say what's halfway in between those two, I have to start with negative 4 because I want to be further from 0. If I started with number 5 and had a number after the -5, I know I would be on this side of -5. So it would have to be -4. And it says halfway. Well, what's half of a dollar? Half of a dollar is 50 cents. So we could put 4.5 or 4.50. It doesn't matter if that's 0, 0 at all. Or let's write it as a fraction. 4 and 1/2. Let's just not forget our negative sign since we're talking about negative numbers. 2 says, which numbers fall between 2 and 3? Give me 2 examples of numbers that would fall between 2 and 3. So some of the examples I thought of would be 2.4. Remember, I know I have to start with 2. I drew my number line, put a 0 in the middle. I know 2 and 3 are going to be to the right. And if I started my whole number part of my number with a 3 and I put numbers after it, it would be to the right of 3, but I don't want to be to the right of 3. I want to be to the right of 2. So I have to start with a number 2. If I were to have a fraction after it, I could put 2 and 1/4. As long as you have a positive 2 to begin with and a number after it, it should work unless you put a fraction in your numerator. Your top number is bigger than your denominator. Number 3 says, are there more numbers than what you marked between 2 and 3? Well, I told you only to give 2 examples. Do my 2 examples match your 2 examples? Probably not. So that tells us, yes, there are more numbers than what we marked between 2 and 3. I could have had 2.1, 2.2, 2.3, 2.4, 2.5. And I could even go make the numbers into even smaller pieces. I could say 2.54 or 2.543. Really, we could go on and on. Number 4 says, where are the integers on the number line? If you remember, integers are just positive and negative whole numbers based on the numbers, or the number lines, that we saw. All of our integers are labeled on our number line because there are positive and negative whole numbers. So they were at every single tick mark, is what we sometimes call these little lines. Okay, so what's next is you are going to go ahead and log in to ClassLink. And then, let me show you, exit out of this if I can. Nope, I don't want to stop sharing. I just want to go ahead and show you what to click on. So after, if you forgot, after clicking ClassLink, you're going to click Connect Ed, and there should pop up your assignments. Today's assignment is going to be to complete pages 6 and 7, and they look like what I have on my screen right now. So your key idea is rational numbers, which are any numbers that can be written as a fraction. The set of rational numbers includes whole numbers, integers, fractions, and decimals that terminate, which means stop, or repeat. So remember, we saw some repeating decimals. 3.333333 would be a repeating decimal. Usually we just put a line over it instead of writing all of those 3s. Rational numbers include integers, which are whole numbers and they're opposite. Positive numbers are greater than 0, which means they're to the right. Negative numbers are less than 0, which means they're to the left. These numbers are rational because they can all be written as fractions with a denominator of 1. So they gave us some examples of integers. And remember, all whole numbers can be written as fractions. They all have that imaginary number 1 as the denominator or as the bottom number. Decimal numbers and fractions have values that are between integers or positive and negative whole numbers. Decimals that terminate or repeat are rational. They're not integers. So negative 2.6, 1.75, and 4.9 are all examples of decimal numbers. Okay, they gave us an example of some rational numbers plotted on this horizontal number line. We're going to go ahead and do a little practice before I let you work on your own. Try this as match each rational number to a point on the horizontal number line. Okay, so for number 1, I see it says 6 and 5/8. So that tells me I'm going to find 6 on the number line. Since there is a number after the 6, does that tell me I want to get closer to 0 or further away from 0? Further away from 0 is correct. So I know I want to go to this direction from 6, And I see my only option in between 6 and 7 is the letter E. So this one must be E. Number 2 says negative 1.25. I want you to try to figure where negative 1.25 would be on the number line and which letter it would represent. Did you notice? First thing you want to do is find negative 1 on your number line. Since there is a number after, or a decimal part after the negative 1, that tells me I'm going to get further away from 0, which is going to be to the left this time since I'm negative. My only choice is letter A. It's the only letter that's in between negative 1 and 2. All right, next up, I see we have the whole number, or sorry, I was looking up here. Next up, we have the number 2.775, or 2 and 775 thousandths. So give that one a try. What letter do you think that would be? I hope you found 2 on your number line first. Since there is a number after my decimal, that tells me I have to get further away from 0, which is going to be to the right of 2. The only point that's in between 2 and 3 is letter C. So I hope you chose letter C for number 3. All right, let me see if I can move this page. How do I get rid of my writing? Oh dear. All right, so what you're going to do, I can't scroll it all over, is try this next page, drawing a point on the number line. Try to plot it closer to the whole number integer, or integer, sorry, not whole number integer, just integer that it is closest to. However, I'm not going to count them wrong as long as you get it in between the correct 2 whole numbers. I'll do one example with you. I'm going to choose one that has 2 different numbers. Let's do number 8 together. So first I see 23.01. So I know first off I want to find 23 on my number line. I know I want to get further away from 0. Well, since these are positive numbers, that tells me that the 0 is over here. On number 6, it gives you 0 because we're talking about positive and negative whole numbers. On number 4, do you notice we're only talking about negative numbers? And 0 is always to the right of negative numbers. So my 0 would be over here in this case. It might be helpful for you to label where your 0 would be as well. Okay, let's get back to number 8. Found 23 on my number line. There are numbers after the 23. So I know my number has to be in between 23 and 24. I noticed right after the 23, though, is a 0, which tells me I got to be pretty close to the 23. So I'm going to put a dot that's closer to 23 than it is to 24 and label it 23.01. Okay. If you put it closer to 24, that would be okay because we're kind of just learning where to place the numbers correctly this time. All right, let's look at the second one. It says 24 and 9/10. So I'm going to find 24 on my number line. Since there's a number after it and my 0 is to the left, I know I'm going to have to go to the right of 24 to put my placement. So it's got to be between 24 and 25. I notice my fraction is 9 out of 10, which is almost the same as a whole. A whole would be 10 out of 10. So I've got to go closer to the 25 than it would be to the 24 and label it 24 and 9/10. Okay, number 10. As you plot a bunch on a bigger number line, you can do this. And then don't forget about the reflection question. Is it always possible to find another rational number that is in between 2 different rational numbers? Explain your answer. So this kind of goes with what we talked about. I sometimes had you list 2 numbers in between 2 integers. Can you think of more than 2? All right. When you are done, you will go ahead and click the turn in or submit button so I can also see your work. Be sure to email me in Schoology if you're struggling with any of these assignments. Now I've got to figure out how to stop this recording, which might take me a minute, so you can go ahead and stop listening. Oh, here we go.